Last speaker of today's session is Dimitris, and he will be speaking about biogas and biomethane. Dimitris Korkumpas is a senior mechanical researcher at CERT. He is specialized in the simulation and development of LCA, LCC for integrated advanced energy systems. His basic scope of research is the sustainable management of energy research in environmental, economic, and social terms, focusing on advanced biomass exploitation technologies with emphasis in biogas, biomethane, renewable energy systems, energy storage solutions, waste management, and CO2 utilization. Please, Dimitris, the screen is yours.
Okay. Thank you very much, Jose and the BioRuler Consortium for the invitation in this nice workshop. My presentation has titled Sustainable Pathways Using Biogas, Biomethane and the Circular Economy Approach. And in this presentation, I will first briefly describe CERT, our competencies, some targets about the biomethane and the biogas sector in Europe, and projects that we are involved. So I think that in the beginning of the workshop, Jose described about CERT. So just to mention here that I'm working at CERT and especially in the Department for Energy and environmental and for the environment. So I'm working in the Chemical Process and Energy Resources Institute, Research Institute, with a lot of activities. I skip this one because this one it was in the beginning of the workshop. So here you can see some of the activities that we do as a group. A lot of activities around biomass and biomass fuels in the chemical processes, CO2 capture and storage and utilization, renewable hydrogen and renewable gases, about biomethane, which is also the scope of this presentation, renewable energy system applications, circular economy systems, and smart grids and advanced energy systems. We have horizontal activities regarding supply chain, process modeling, CFD, life cycle analysis and sustainability analysis, cost-benefit analysis and techno-economic assessment, as well as ICT activities with the aim of optimization of energy use, cost, and carbon emissions. As a group, we started from fossil fuels, and then we have a transition to the renewable and biomass fuels. And as you can see in the picture in the center of this slide, we organize different, let's say, pillars under a circular economy framework. Here it's our group competencies, especially for circular economy and for life cycle analysis and life cycle costing, that I'm leading the group here at CERT. So based on the reports and on the needs of the industries, we can estimate environmental assessment and economic assessment under a sustainability framework in order to provide guidelines to the industries about their environmental footprint and economic, let's say, analysis. Some of activities that we do on that sector is, of course, supply chain design and optimization of logistics, the production of zero green carbon negative chemicals and fuels for circular bio-based. We estimate this one. We develop algorithms for LC and LCC. We develop multi-criteria analysis for estimation of processes under different pillars, economic, environmental, and social. We develop business models, and as I mentioned before, also we develop an ICT platform that we will see later on in the project, how we have developed this one, and what is their use. Regarding biogas and biomethane sector, we provide the whole package, starting from the feasibility studies, research about the availability of raw materials for use as substrate. We make all the basic mass and energy balances for integrated solutions. We support technically biogas plants, and of course we do all of the other horizontal activities that I mentioned in my previous slide. We have a very standardized laboratory for characterization, first of all, of biomass and for biomass pretreatment. You can see here some of the analysis that we do in the substrates, while also we have analytical equipment for biogas measurements and measure biomethane potential in order to estimate biogas and biomethane in using different mixtures of substrate. We start from a laboratory, as you can see, laboratory activities, and we reach also in TRL 5. We have a pilot reactor, so we can simulate the activities in an industrial biogas reactor in this one pilot reactor with a capacity about 20 liters. Now some issues about biogas. Biogas is of course an energy resource, and by upgrading of biogas, biogas is from methane and CO2, and upgrading biogas we can reach to biomethane. Of course, we have a digestate that can be used as a fertilizer, and this one is also can be characterized with the latest regulation frameworks, FPR 2019. But apart from those products, digestate and biomethane, we have also a new one, the biogenic CO2 emissions, but now there is quite a big discussion in Europe about its use, and we'll see later on a project that we are involved, and the basic scope is to produce biochemicals using these biogenic CO2 emissions. There's a lot of discussion about biomethane targets in Europe, and especially in Repower EU plan, that we can see this one in this slide. Of course, the main scope is how we can proceed to be independent on fossil fuels. So Europe promotes biomethane. As you can see here, the target is quite high. It's about 35 billion cubic meter on 2030, while now it's only 3 billion cubic meters. So you understand that the target is too high to achieve, and we have to develop a new biomethane plants in order to achieve this target. Here we can see also the allocation of biomethane production based on the origin of the feedstock. European Commission also has the Repower plan has also set some targets on that. And as you can see here, livestock manure has the main contribution on that, while following from agri residues. Industrial wastewater has the less, let's say, contribution in this target of 35 billion cubic meter. Here it's some key issues about the Repower EU. As we mentioned, we would like to utilize, Europe promotes to utilize feedstocks from different sectors, from agricultural sector, from municipal sector, from industrial sector, especially manure, sewage sludge, and other bioproducts from industries, to produce biogas and then upgrading to biomethane. There is also prioritization to sustainability, so encourage life cycle assessments to ensure the overall environmental impact remain positive, and in some times we use also the negative emissions when we store let's say CO2 and then we utilize in an added value product. And finally, it's quite significant to unlock local potential, because as we can see also in the project that we are involved, there's a lot of potential for producing biomethane, but because of some problems, especially logistics and in the supply chain, this one is, remains locked. So it is quite critical how we can unlock this one and to proceed to investments in biomethane sector. Let's continue with the first project that I would like to present in this workshop. First of all, it's a biomethane project. Here it's about demonstrating and connecting the production innovations in the biomethane universe, the title. Here we have to develop some technologies, new technologies, especially for biomethane production, in order to reduce the overall biomethane production cost and increase biomethane production compared to conventional technologies. In addition, we have to estimate their sustainability and to have some to estimate the environmental footprint, the economic evaluation of those technologies, and of course to propose how we can replicate this one. This one is quite significant in Europe, how we can replicate those technologies, and how we can go to the next let's say level to upscale of those technologies. We have 5 demos in 5 different countries. First of all, it's in Greece, where SERF is the demo leader, and here it's an ex situ thermochemical catalytic methanation using hydrogen. We will see in the next slide more details about that. The second one is the French. It's in situ and ex situ electromethanogenesis for enhancing biogas production using electricity. The third one is Italian use case, ex situ biological methanation for upgrading of biogas using hydrogen for the treatment of the raw material through ozonolysis. Here it's about especially for sugar sludge as a feedstock. Ex situ biological methanation of synthesis gas from thermal gasification. And finally, we have in Ukraine use case with in situ biological methanation. Here, the hydrogen incorporation into the anaerobic digestion reactor in order to produce high quality methane. About now the biomethane in pilot plant in Greece. Just to clarify that in Greece we have not yet a biomethane framework, a legislative framework for biomethane production. So this one will be the first pilot plant that will be developed in Greece. It will be located in biogas plant, industrial biogas plant in Lagada in North Greece. Biogas Lagada is also a partner in the project, and we call it this demo. Some technical specifications about the biogas plant in Lagada. That they use about 80,000 tons of livestock waste per year, produce 8,400 megawatt hours of electricity, and produce around 75,000 tons of digestate suitable for to be used in for fertilizer as fertilizer. The capacity is about 300 cubic meter methane per hour, They operate two fermenters, and the total flow is about 500 cubic meter per hour at 100 millibar. The capacity is 1 megawatt electrical, and here it's I think that the most details maybe you will see tomorrow in the second day from the presentation of my colleague Themis that is working for Biogas Lagada. So some issues about a brief description about the technology. As we mentioned, this one's thermocatalytic technology. So there is the biogas with input biogas flow about 6 cubic meter per hour. The composition is around 6% methane and around 40% carbon dioxide. Of course, there are also some more, let's say, impurities. And after the purification, you can see here the hydrogen and the thermocatalytic process in order to produce biomethane using the CO2 and the hydrogen. So this one is something that has not been, it's a technology not demonstrated for biogas. So we start from TRL5. There are some pilot units around the world that doing this work for syngas, but not for biogas. And now we are working in order to find the most, let's say, suitable configuration for the methanation section, working on the catalyst performance in order to produce high quality biomethane. Next steps, it's about the erection of this biomethane plant in Lagada, using all the integrated with all other components, like, for example, hydrogen tank and providing hydrogen in this pilot plant. This one's the second project. It's the Alpha project. It's about the unlocking, as we mentioned before, of potential livestock farming. It's an Horizon Europe project, and here we have the main, let's say, objectives. First of all, is the research, the state of the play of biogas technologies in 6 European countries: Belgium, Denmark, Spain, Greece, Italy, and Slovakia. It's to design some business and technical services, okay, and to provide those services to more than 50 livestock farmers. We have an open, let's say, call in the previous month, and we'll have also a second round, call in the next period. Excuse me. So if you like to participate, please visit the webpage of the project, and please, or you can send me an email if you are interested. If you are a farmer or a biogas plant that you are interested in order to provide you some services, this is free of charge. So in this project, we have also to engage stakeholders to develop platform and tools for the whole activities that we do, and to increase the social acceptance of biogas solutions. We have created hubs to communicate it with local partners. So we have hubs in Belgium, Italy, Denmark, Greece, Spain, Slovakia. Here we have some challenges and potentials. You see that in most of the countries there is some, let's say, low, let's say, biogas plant investments compared to waste. There are also, in some countries, there are also some insufficient financial incentives in order to promote biogas plants, investments in biogas plants, but for this reason, the hubs has been created. So we'd like to discuss with all of you about potential services that we can provide to you. Here we have some indicative services, especially business services and technical services. Regarding business services, we can provide market research, business modeling and planning, access to finance support, corporate and sustainable finance, and farmer-to-farmer advice. While for technical services, that Seth is the leader, and so you can communicate it with us. We can provide concept design and development of biogas systems to evaluate the biogas potential based on preliminary calculations, to estimate the process and the proposed solution under an environmental assessment analysis, to monitor any biogas solutions already exist, and to provide some optimization, optimized solutions, and to support farmers in evaluation comparison with planned suppliers' codes. The third project, and the last one that I would like to present, is a Cosmos project. This one's about the utilization of biogenic CO2 emission. As I mentioned before, there's a big discussion about this one in Europe. So in this project, we provide a platform with different technologies in order to utilize biogenic CO2 emissions through these technologies and to produce different bio-based chemicals and biopolymers. It is important that based on this one that the European Commission proposed, that since this one is about biogenic CO2 emission, this one can be captured, utilized in a product as a chemical, so has negative emissions. This one is quite important for the environmental assessment and for the sustainability of the processes. Here you can see different technologies that the consortium of Cosmos used. It's about gas fermentation, electric catalytic reduction, biocatalyzed conversion, liquid fermentation, catalytic conversion. So we like to produce chemicals with low energy utilization, less than 50 kilowatt hours per kilo, low production cost, less than 1.75 euro per kilo, with high product yields, and to have also savings emissions by using biogenic CO2 emissions in these added value products. Here, it's also quite, we like to present that we develop a platform, an online platform. This one will be an online platform. Now it's under construction. We think that by the end of the year will be operated. So in this platform, the stakeholder can, let's say, make a first assessment, a preliminary assessment about the pathway that they would like to follow based on their needs and their project. So it will be a platform to evaluate the pathways. You can see here some indicative screenshots that the stakeholder, the user, can select different, let's say, parameters that they would like to investigate, and then we'll have the final results. Before to close, just to mention about CERT, that our group is working especially in two fields, in energy and in environment, and we provide services in industry, but also taking into consideration always the society needs. So we propose research and innovative projects in order to have to propose something more sustainable to the industry. Thank you very much for your attention. I hope I was on time. And if you'd like to contact me, here is my contact details, and I'm happy to discuss with you for any questions that you may have. Thank you very much again by Rural Project for the invitation.